to do any kind of research, we want to make sure you're doing good research that's producing that kind of dependable knowledge that we can rely on. But secondly, we also want you to be good consumers of research, and this is an important point. Even if you never do a study for the rest of your life, you're just not interested. We are always in our practices and in our daily lives confronted with a lot of different research reports and things that we're reading, right? And we want to make sure that you are able to read those correctly and able to kind of decipher what's good research from what's just, kind of BS, right? It does exist, for sure. But you'll at least be literate and you'll be able to recognize and question that kind of research. As for the potential for fame and fortune, I mean, we're in education, so I really don't think so. I wouldn't get your hopes up. But if it puts your mind at ease, there's actually structure in academic research that protects us from a lot of the bad research out there. And so we'll get into that a little bit later in the course to show sort of what safeguards are in place. And then number 6, there's the assumption that science can't provide all of the answers to all of the questions. That's true. Science can't answer everything. It has limitations. Scientific method is designed to answer particular kinds of questions, like what and how. And it's very well equipped to answer these kinds of questions. But it can't really answer why questions, right? Doesn't provide us with any moral guidance at all. So science can tell us how to build a nuclear bomb, but it can't tell us whether or not we should actually drop it on anybody. These questions are usually better handled by philosophy or literature or religion as well, can help us answer those kinds of questions, and science doesn't really do very well with that. Okay, so let's move on to the difference between theories and laws. People often get these confused. So we'll talk about gravity, for example. Gravity is both a theory and a law, right? They're different. The law of gravity describes kind of the things that we observe. It's expressed sort of in a mathematical equation, and it kind of looks like this. There's going to be a mathematical equation here. The theory of gravity, on the other hand, is an explanation of why we observe what we observe. It has something to do with the force of attraction between masses. Again, I'm really not a physicist, so. In social sciences, we have no laws. I mean, it's not like we're anarchists or something, but people are way too variable in their behavior for us to describe them anywhere nearly as reliably as the law of gravity might describe, like the moon's orbit around the Earth. Anytime you propose a law of like human behavior, you're always going to find somebody doing something to break that law.
Breaking the law, breaking the law, breaking the law, breaking the law.
Right? And if the law can be broken, it's not a law, at least in scientific terms. So we don't have laws of social science, but we do have quite a few theories. Frequently, you'll find a number of competing theories to explain the same phenomenon, right? Which we can then, do some testing and things like that to see, does this hold up or not? Okay, so let's talk about the scientific disposition. The word prove often gets thrown around a lot in connection with research. This idea of proving things is really old-fashioned. Rather than proving, researchers actually find evidence in support of a theory or a hypothesis, but they don't prove it. Traditionally, science has been viewed as a finite archaeological project in which researchers scrape away the crust of human ignorance to reveal the shape and color of the old dead truth of the universe beneath it. This perspective is obsolete. And we now view science as an organic project without a single endpoint of perfect understanding, in which we are engaged in developing an ever-growing body of knowledge that requires pruning from time to time for the sake of good hygiene. I wrote that. It's pretty good, huh? Another aspect of the scientific disposition is tentativeness, which means sort of a reluctance to state things in absolute terms, to kind of admit that you might be wrong, to sort of back away from having like this really absolute certainty. There have been a lot of cases in history where, something that we believed to be true, like everybody believed, turned out to be incorrect. Something like flat Earth, or a geocentric universe, where the Earth was at the center and the sun. So if we learn from these lessons of history, right, we have to admit that we never really know when the next discovery is going to come along and turn everything on its head. There's sort of this thing, it's a Donald Rumsfeld quote.
There are known knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know.
And we never really know the full extent of what it is that we don't know, right? So it makes sense to have a little bit of tentativeness when we make our claims. Therefore, we're much more reluctant to claim we've proven anything. We just find evidence in support of a theory, because we never really know what other information is out there that might challenge it. Similarly, science doesn't do a very good job of disproving things either. This is referred to as falsifiability. So to give you an example, right, you'll take the existence of God. If you're an atheist, you might not believe in God. You might say that there's a lack of accepted scientific evidence that would support the existence of God. But you cannot honestly claim, from a scientific perspective, that God absolutely does not exist anywhere, right? At best, the only thing you can say is that you have not yet found evidence of God in the places where you've looked for him. Key word in that sentence is yet, right? Because there's always the possibility that some evidence will present itself at some point in the future. Since there's neither concrete scientific evidence for the existence or the non-existence of God, we're all left to our own personal beliefs on the matter. If I can give you another example, let's take the legal system, in which people are considered innocent until they're proven guilty. So imagine, what if it was like the other way around, where if you're considered guilty until proven innocent? Can you conclusively prove to me that you've never murdered anybody with an axe? Right? Sure, you can demonstrate maybe on some occasions when I wasn't looking that you weren't murdering people, but how am I supposed to know that you've never done it in your entire life? Maybe you're pretty good at coming up with excuses and alibis. You're pretty sneaky, So obviously, the claim that an axe murderer is not falsifiable. You can't ever really conclusively prove that you've never, in your entire life, murdered somebody with an axe, right? On the other hand, it's much easier to prove that one single instance where you have, right? If you have. I hope you haven't, of course. But that's why we always have innocence before guilt, the assumed innocence before guilt, rather than the other way around, right? Because you can't prove your innocence, you can only prove guilt. Does that make sense? I hope so. If not, don't kill me with an axe.
Don't murder me. I beg of you, don't murder me.